let's try to understand the very famous problem, longest common subsequence. Longest common subsequence. I mean, it is one of the famous problem in subsequence problems actually. So the problem said that given the two strings, let's say A, B, C, D, E, and A, C, E. Now we need to find the longest common subsequence between these two strings. So what is the longest common subsequence between these two strings? So one is A. What like if we skip B and D, so we'll get A, C, E, and this matches with A, C, E. So this is the longest, and the length is 3. So 3 we need to return. Okay. Now this now how we can get this 3? So that's matter. So in our eyes you can see like, okay, AC and AC is common, that's why we got 3, but we need to write an algorithm for this, right? So how can build that intuition, right? Okay, like we can write an algorithm to solve this problem. Okay, so let's check that. Okay, so let's say A, B, C, D, E, uh, A, B, C, D, E, and we have A, C, E. Okay, so we can see like A and A is common. Okay, A and E is common, so we can get like, okay, so in that case 1 will be our length so far. Okay, our in the LCS so far. Okay, now B, now we are left with B, C, D, E, and C, E. Okay, now B and C, now this is the trick over here. B and C, this two is not common. Okay, so now if these are not if these letters are not common, then we need to find a solution, like how can get the longest common subsequence between these two. Okay, so you can see like B, C, D, E, and C, E. Okay, so now what we can think, like this B and D, if you remove, then we are getting C and E. Okay, but if we remove now how can we find like B and D will remove? Okay, but if we at least remove B and if you at least remove B, then we'll be remaining with C, D, E, and C, E. Now C and D, C, D, E, and C, D, E, and C, E. Now C and C is common. Okay, C and C is common. Okay, so in that case we can still get a length 1. Okay, and that will be added to the longest common subsequence length found so far. Okay, so we can see like, okay, so that is one choice. Now another choice we need to make, so we can make two choices over here. So either we can remove the first letter from the first string, or we'll remove the first letter from the second string. Okay, so we'll have two choices over here. So C, D, E, C, E, and on the right will be keeping B, C, D, E, and we'll remove C, so we'll be remaining with E. Okay, now C, D, and C, E, this again we got common, so this will be added 1 over here. Okay, so this will add 1, C, D, and C, E, so this will get 1. Now D, E, and E, now this particular part, so this we got 1, C and C was common. Now this particular part, D and E, is not common, so again we have to make two choices. So choice 1 will be if you remove the first letter from the first string, so it will be E comma E, and if you remove the first letter from the second string, it will be D, E comma blank string, or other empty string. So in that case, so this will be 0, and over here we got common 1, 1. Okay, so now this part is done, the left part is done. Now let's do solve the right part. Now over here B, C, D, E, and E, now B and E again is not common, so we need to do C, D, E. If you are removing the first letter from the first string, C, D, E, and E. Okay, and again if we remove again we'll have two options. So like again we'll be having on the right, what we'll have, so B, C, D, E, and will be remaining with empty string, because if you remove the first letter from the second string. Okay, now this will return 0, but let's solve again. We are remaining with the letters in the string. So over here again C and E is not common. Okay, so again we'll be having, we need to do, have to make two choices. So we'll be having D, E and E, and on the right we'll be having um, on the right we'll be having D, C, D, E and empty string. Empty string. So basically empty string. Okay. Now empty string. Okay. Now D and E and C, D, and E. Okay. Now again this will be will get as 0. So this will get empty string and CD. What will be the subsequence? So there is no can be going to be any subsequence only, right? I mean, how can I get the subsequence between an empty string and a string like which is having letters? Okay, so this is written 0, and on the left we'll get D and E. Now again we need to solve where D and E is not common, so we need to make choices. Okay, so on the left we'll be having E and E, and on the right we'll be having DE, and if you remove the first letter from the empty string, so we'll be remaining with empty string. So this will be 0 and this will return 1. Okay, now okay, so now this part like over here, so that problem say that we need to find the maximum or the longest common subsequence between those two strings. Okay, so D, E and E, what will be the longest common subsequence? So E is the longest common subsequence, and how we are getting that? Because on the left we got 1, on the left we got 1, on the left we got 1, on the right we got 0. So if we do maximum between 1 and 0, if we do maximum between 1 and 0, then we'll get 1. Okay, which we can see in our eyes as well. Okay, now CD and CE, there was a common letter, the first letter was common, so we already got 1 over here. So this particular CD and CE will get C as CE will common, so basically we'll get 1 plus 1, which is 2. On the left we'll get 2. Okay, now on the right. Okay, so now this E and E will get, we are getting 1 over here. D and E is 0, so this part we are getting 1, on the right part we are getting 0. So D and E we are getting 1 over here. So this part 1, maximum of 1 and 0, what will get? It will be 1 only, no? So this one will be 1, and CD and this is will be 0. Okay, now CD and E, what will be the, so this CD and E, so what will be the what will be the result? CD and E, we are only common is 1, because E is the common, so this maximum of 1 on 0, so that will be returning 1 only. And B, C, D, E and E, so this is what is the common between these two? So common is only E, so there also we are BCD and empty string. So let's say the BCD and empty, so this is 0, so this returns 0. So BCD and E, so basically E is common, so basically that's what we'll be getting 1 over here, because BCD and E is the common. Okay, now over here BCD and E, so on the left we are getting 2, on the right you are getting 1. Okay, so now if you do maximum between 2 and 1, so maximum between 2 and 1, what will be the answer? 2 is the answer. And then 2 plus 1, if we do less, so 2 plus 1, that is 3. So 3 is the longest common subsequence between two strings, right? Now we can see over here, I mean, we are solving this using substrings, but is it the right way? Because if you are solving with the substring, then we are done then, because getting the substrings also will add some complexity over here, or time complexity over here. So getting substrings and then comparing between things is not a nice way to get the LCS over here. So what we can do over here rather, okay, so what we can do over here, rather we are doing this substring approach over here, we can think of taking index over here. So as you can see, like when we if we are having two indexes I and j, I is pointing to 0, j is pointing to 0. Okay, so when we consumed a and a, we move to the next part, so which is b, c, d, e and c, e. So this is nothing but we moved our pointer over here. Okay, now when we are not getting, so we are making two choices, so one was we are doing 1 2 sorry 2 1. So we are making 2 1. This is 2 1. So we are making two choices, and this is 1 2, nothing but 1 b, c, d, and e, 1 2. Okay, so you can see, like we can say over here, so when case 1, for case 1, when the if the letters of both the strings are not same, then we are going, or we are moving, my bad, we are moving to next index by adding 1. So 1 plus f of 1 comma 1, what we did over here. And when case 2, when the if the letters of both the strings are not same, then what we did, we made two choices. So then we made two choices or decisions or options, whatever we can say. So then what we do it, we did a maximum, we calculated the maximum between f of 2 comma 1 and f of 1 comma 2, right? And now if you can see, like we are going depthwise, right? So we are going depthwise in the sense, like, okay, we are, once we are done with a b c d e, then you are solving for b c d and c e. So basically you are solving the same problem, like we are solving the problem recursively, right? And passing the, what is the parameter which is changing, only the strings, the two strings are changing. Okay, so, and or you can say like indexes are changing over here as we move to indexes rather than substrings. Okay, so we can see, like we are taking help of recursion over here, and we are going depthwise. Okay, and then we are finding the longest common subsequent between these two strings. Okay, but if you see over here, although we are taking recursion, you can see like we have overlapping subproblems. So how you can find, now DE, this DE and E, so this D and E we are solving twice. You can see like D and E we have also solving over here. Okay, E and E we are solving over here also, we are solving over here also. Okay, D and this empty string we are solving over here also, we are solving over here also. So we have overlapping subproblems. Okay, so you have overlapping subproblems, and whenever we are having overlapping subproblems, so that there is a chance to optimize with dynamic programming, right? Okay, now before going with dynamic programming, so as you are taking recursion over here, we need to find the base case. Okay, so what will be the base case? So base case will be if we reached in the end of the string, either over here you can see, like, so we reached over here, we reached the end of the string, so empty string. So if the reach the end of the string, then we can say like there will not be any subsequence. So if we write a function f of I j m is the length of the first string, n is the length of the second string, s1 s2 is the string, s1 and s2 is the first string and second string, then we can say base case we can put if I is equal to m or j is equal to n, return 0. Okay, now we have two cases. One is the first letter of the both the strings are same, and on the second case is the first letters of the both the strings are not same. So you can say if s1 of I is equal to s2 of j, then we can say return 1 plus f of I plus 1 j plus 1 m n s1 s2. So first case is done. Second case is return, we can say return maximum of f of I plus 1 comma j m n s1 s2, and alternatively we need to remove the letter from the second string. So f of I j plus 1 m n s1 s2. Okay, so if we do this, then we'll get our answer. But what will be the time complexity? So as we are using recursion over here, so time complexity will be 2 to the power m plus n. Okay, so basically each letter either it can be part of the subsequence or it cannot be part of the subsequence. So two options we are having. Okay, and space complexity would be maximum of m comma n. In the worst case, complexity is nothing but for the auxiliary stack space we are using over here in this recursive approach. So over here you can see like we reached up to 5th level, right? So a b c d e is the length of the first string was 5, right? So we almost reached up to 5th level. So 1, this is 1, this is 2, this is 3, this is 4, this is 5. So that's why maximum of m comma n if we do, then but the second string was of length 3, so but we reached up to 5th position or 5th level, right? So that's why we have put maximum of m comma n over here, right? But we can see like we already discussed over here, like we have overlapping subproblems. So in like when you have overlapping subproblems, then we can memorize it. So with the help of top-down dynamic programming or recursion with memoization or top-down DP, or we can say larger problems to smaller problems, because we are solving from larger problem to smaller problem, so that's why we call it as top down, right? So let's so to memorize it, we can take help of a DP table of size m n. Okay, initialize with -1. Okay, we can initialize with -1, and then what we can do, like, okay, so we'll write the same function again, f I j m n then s1 s2, and pass this dp. Okay, now over here what we can do, like we'll copy the same base case. If I is equal to 0, m or j equal to n, then return 0. Okay, if it then we have to if we already memorize the value, right, then we can say like we can check in the dp table. So if dp of ij not equal to -1, then we can return dp of ij. Simple, right? And then we'll write the first case over here. So if s1 of I is equal to s2 of j, then return dp of ij. So we need to memorize the value as well. So if you have found the solution, so dp of ij is equal to 1 plus f of I plus 1 j plus 1 m n s1 s2, right? and pass, don't forget, pass the dp as well. Okay, every time I forget. Okay. And then we can return. So this part, first part is not successful. If first is not validated or is not valid, then it's we need to is not valid, then we can say return dp of ij is equal to maximum of f of I plus 1 j comma m comma n comma s1 s2 comma dp. Oh man, this is, it is not letting me write. Dp, and then I j plus 1 m n s1 s2 comma dp. Okay, so this is done. Okay, and so this is done. Okay, so now what will be the time complexity for this? So time complexity would be m into n. Okay, space complexity will be, we are using a dp table of size m into n, and then we are still using the recursion call stack or auxiliary stack space over here, so which is maximum of m comma n, which is discussed over here. Okay, okay, so now how can we remove this auxiliary stack space? So if you have to remove auxiliary stack space, then one thing we can think of taking tabulation. Okay, so tabulation is the bottom up, because we solve the smaller problems first, smaller problems to larger problems. Okay, now let's take an example and let's draw a table over here. So let's draw a table. Okay, okay, A B C D E, and on the left we have A C E. Okay, so this part we'll draw the lines. Okay, draw the lines, sorry about the bad handwriting. A B A C E, and then over here and what we discussed over here, base case. So if we reach the end of the string, so either of the string reached end of the string, then we return 0. So you can say we can fill the last row and last column, so at least we got something to fill. Okay, finally. Okay, so this will return 0, because if you are having empty strings, we cannot get a subsequence. Okay, all right, now this why this eraser is coming, this C, this cell, what will be the value of this cell? What will be the value of this cell? So basically currently we are doing for CE and CDE. Okay, so we can see over here, when we solved CDE and CE, we added 1. We added 1 because C was common, and then we look for D and E. Okay, so D and E is where? D and E is where? So D and E, D and E. So this, sorry, this D, E, this E, and this DE. Okay, so this DE and E. So this is basically this one. Okay, this cell, and then we added 1 over here. Okay, this added 1 over here because C was common. So in that case, we can say first case, for the first case, so first case would be 1 plus dp of I plus 1 j plus 1. So this will be the value of dp ij. Okay, now let's solve this second case, where both are not same, like both the first letters of both the strings are not same. So over here, let's take an example over B C D E. B C D E, is it B C D E? Yes, so B C D E and A C E. Okay, so we need to find what will be the cell value of this. Okay, so BCD and BCDE and ACE. So BC, let's write over here BCDE and ACE. Okay, and B and A is not common. Okay, so what we did solve about maximum of f of, we removed the first letter from the first string, so C D E, and then we kept ACE as is, and then we kept BCDE as is, and then removed A from CE, so it becomes CE. Now where it resides, so CDE and CDE and ACE, CDE, so this part CDE, this cell, and ACE, so this cell, so this basically this cell ACE and CDE, so this cell, okay, this cell. Okay, and another is BCDE and CE, BCDE and CE, so basically CE and CE and BCDE, so this part BCDE, so this cell, right? So for the case 2, then we can write so for the case 2, so second case, we can write dp of ij is equal to maximum of dp of I plus 1j, this cell I plus 1j, and this cell, so this p of ij plus 1. Okay, so second case is also done. Okay, now I think we got the sufficient cases over here to fill the table. Okay, so now we can write the function as f of s1 comma s2 if s1 dot length is greater than s2 dot length, so we can return f of, we'll call the same function again with h2 and s1. So basically this will, what will do, it will basically swap s2 s1 with h2. Okay, this will basically help to swap with s1 s2. Basically we want to keep s1 the smallest and s2 as the largest, like over here. So basically this will be s1, this will be s2. Okay, then we'll get m is equal to s1 dot length, we'll get the length over here, n is equal to s2 dot length. Okay, then what we need to do, we need to fill the last column and last row as 0. Okay, so you can write for I is equal to 0, I less than is equal to m, I plus plus. Before that we'll declare a dp table of m plus 1, n plus 1. Okay, so over here dp of in is equal to 0, so this is basically will fill the last column as 0. Fine. Now we need to fill the last row as well. So in that case, for j is equal to 0, j less than is equal to n, j plus plus. Okay, and what is the last column we can, sorry, last row, it will be dp of m, and it will be j, so this is the variable index. Okay, and we will put 0 over here. So this will help to fill the last row. Okay, all right. Next, what we need to do, we need to run two loops. So for I is equal to m minus 1, so you already fill the last row over here. So we'll start with I is equal to m minus 1, I greater than is equal to 0, I minus minus. For j is equal to n minus 1, j greater than is equal to 0, j minus minus. Now over here we have two cases over here. So if s1 of I is equal to s2 of j, then we can say dp of ij is equal to 1 plus dp of I plus 1 j plus 1, like we have done over here, right? So dp of I plus 1 and j plus 1. Else we can say dp of ij is equal to maximum of dp of I plus 1j, dp of I j plus 1, which you already discussed over here, second case. Okay, now we'll be out of this inner loop and the outer loop. Okay, and then we can simply return dp of 0 0, because the first cell, this particular cell will be having the result, so which will be having the longest common subsequence length between ABCDE and ACE. Okay, now what will be the time complexity? So time complexity would be m into n, and space complexity would be m into n only, because you are using a dp of size m into n, or although we have taken a size of m plus 1 or n plus 1, we can say like dp of like m space complexity of m into n. Okay, now can we improve the space complexity over here? Okay, let's take that. So over here you can see like for this cell, right? So for this cell, when the first letter of both the strings are same, then what we did, so basically we referred the cell diagonally, so basically which is nothing but, so if we say this is previous and this is current, so basically what we refer, we basically, and this is just row, this is row wise, this is row, so basically previous of row plus 1. So this basically, if this is the row, then we just one index greater. Okay, so this is previous of row plus 1, and when the, for case 2, when the first letters of both the strings are not same, then we refer over here. So basically in that case, if this is current and this is previous, okay, so basically what we are referring, so basically what we did, so current of row plus 1, basically this one, and for this, what is this, it will be previous of row, right? Same row we are having over here. So this basically becomes case 1, previous of row plus 1. So this is become case 1, and this is case 2, where we need to do max between this current of row plus 1 and previous of row. Okay, previous node just crashed. Okay, so So for what we discussed, so for case 1, okay, so it will be 1 plus previous of row plus 1, okay, and for case 2, what we discussed, so this will be maximum of uh, previous of row and current of row plus 1, right? Okay, so now what we can do, so we'll take the same function f of s1 and s2, okay, we'll do the same trick. If to keep s1 as the smallest, s1 dot length is greater than s2 dot length, then return f of s2 comma s1, okay. So this is done. So this is, we swapped s1 and s2 already, as we already done before. Next one need to do, we need to declare two variables. One is m is equal to s1 dot length and n is equal to s2 dot length, okay. We'll declare two 1D arrays, okay, 1D DP arrays. So basically this will be previous of m plus 1, because m is the smallest currently, and with initialize initialize with 0, okay. Then current of m plus 1, so basically this will be also initialize with 0, okay. Now we need to run two loops. So one will be, so for each column we need to evaluate rows, right? So in that case, for column is equal to n minus 1, so column will be in the outer loop. Column is equal to n minus 1, column greater than is equal to 0, column minus minus. For row is equal to m minus 1, row greater than equal to 0, row minus minus, because we are evaluating for each column, we are evaluating the rows, okay, from the previous column and from the current column, okay. So and we need to do check two cases, okay, we need to solve two cases. So if s1 of row is equal to s2 of row, s2 of column, then what we discussed over here. So basically it will be current of row would be 1 plus previous of row plus 1, the diagonal cell, okay. So this is done. Else current of row would be maximum of current of row plus 1 comma previous of row, okay. So current of row plus 1 previous of row, maximum of, okay. So this part is also done, okay. Now we'll be out of the inner loop, okay. Then what we need to do, so we need to swap a previous and current, because current will become previous, okay. So in that case, what we can do, we can take help of a temporary variable, temporary equal to current, and current becomes previous, and previous become temporary. That means current. Okay. So if we do this, then what will happen? Like temporary, that previous and current will be swapped. Okay, the both the 1D arrays will be swapped with each other. Okay, and then where will be the result? Tell me. So will be so we earlier we calculated A, B, C, D, E, and this is A, C, E. Okay, so this is current, this is current, this is previous. Now after end of this loop, after end of the inner loop, so we have swapped previous with current, so this becomes previous. Now result stores over here. Okay, result is stored over here. So in that case we can simply return previous of 0. So previous of 0 will be having the result. Okay, the length of the longest common subsequence between these two strings. Okay, now what will be the time complexity? So time complexity will remain same because you are running two loops. Still we are running two loops. So of m into n. Space complexity now will be reduced to m. So basically whichever is minimum, so O of minimum of m into n. So basically whichever, I mean that's why we have swapped over here, right? We have swapped over here. Okay, so in that case, so this will be the space complexity. Now we have understood the algorithm. If we have, okay, so now what is the real world application for this algorithm? So in real world this algorithm along with other algorithms is being used in genetic analysis. Okay, so genetic analysis. Okay, so if we have DNA 1 and DNA 2, so what is the longest common between these two DNAs, as we have seen over here. Next is Git is basically uses this during deeping or merging between two branches. So basically Git uses this while deeping and while merging between two branches or comparing between two strings. Okay, comparing between two strings. Okay, all right, so I guess you like this lecture. Okay,